An exothermic reaction occurs when the energy used to break the bonds in the reactants, or the starting stuff, is less than the energy released when new bonds are made in the products, the stuff you end up with. This extra energy is given off as heat, and there's a temperature rise around the surroundings of the reaction. Take a look at the graph. The energy of the reactants is much higher. There's a burst of energy, and at the end of the reaction, the energy in the products is much lower. Think of any combustion or fire burning. The energy in the gasoline is much higher than after the energy at the end of the reaction. In the products, all of the energy during that reaction is released to the surroundings. An example equation is propane gas that's burning. This equation is written as C3H8 plus 5O2 yields 3CO2 plus 4 waters, H2O, plus heat. Take a look at this reaction in real life. This is a propane reaction. The energy in the propane in the reactants is much higher than the energy in the products. During the reaction, heat is released. So, how does this reaction feel? You can probably guess it. It feels hot. During the reaction, heat energy is released. Can you think of some other examples of reactions where heat is released? Well, any combustion, fireworks, freezing water is actually one. The energy is higher in water before it's frozen. After it's frozen, think about it, there's much less energy in the ice than there was in the starting reactant. Condensation is another example. Compare the energy in steam to the energy in droplets of water after it has condensed. The energy in the steam is much higher than the energy in the droplets of water. So during condensation, energy is released. Rusting iron is another example. Finally, over in our last little flap, reactants have more energy than the products. The reactants have more energy than the products. Take a look at your graph up here. Can you tell in the endothermic reaction graph, the energy of the reactants is much more than the energy of the products. This is the amount of energy that is released in the form of heat.